everyone, you're welcome to my channel. My name is Promise AK, and on this channel we talk about everything you need to know about data science, data analysis and related topics, covering everything from the basics to advanced techniques, helping you transform from a beginner into a data expert. If you're passionate about these subjects or looking to learn more, make sure you hit that subscribe button and click on the notification bell so you never miss an update. In today's video, we'll walk through a data analysis project focusing on analyzing student exam scores based on various attributes. You can find the link to the dataset in the description, so feel free to download it and follow along. To get started, we'll be launching our Jupyter Notebook. If you're new here and not sure how I got to this point, or you need help opening or downloading a Jupyter Notebook, don't worry, I've got you covered. Check out the info card or the description for the link to a tutorial video on how to download, install, and open up your Jupyter Notebook. To begin, we'll import all the libraries we need. We'll import pandas, numpy, matplotlib and seaborn. Next, we'll import our dataset using pandas. So if you use pandas.read.csv and impute the path to the file, in this case I have my file in the same folder as my notebook, so I just need to call that and run that block of code. Read that. Let's see. So we have this stored. You can check this, start exploring what we have. The .head, so head gives you the default head gives you the first 5 rows. So this is what I have. Okay, so I have 8 columns, and this looks to be numeric. But I could confirm to see what different kind of data I have in there. So I could print out df.info. Okay, let me see. So showing me I have 1,000 entries. I have 8 columns, and they are, so these last 3 are all integers. Makes sense. And these have we have 5 numeric columns. That makes sense. So the next thing you want to do, maybe you want to describe the data. Let's see, df.describe. This gives us like the statistics of what we have, how many values we have in each of the scores, what the mean score is. So for example, for math score, we have our mean at 66. For reading score, we have our mean at 69, and writing at 68. You see the standard deviation of your data. This just gives you numeric statistics of the data. So next, let me check if I have any missing data in my data frame, any missing row, missing column. So nf dot is na. Then so it's when you do this, you run df.isNA, it just gives you this true false. So if, for example, I taught you about booleans before, false is 0, true is 1. So but I don't want it wouldn't really make sense or give me any meaning information coming up as this. So I just wanted to like a sum. So sum all the rows where I have missing values per column. So what this does is, okay, add all the false 0 plus 0 is 0. So all the false will be zeros. Then if I have any true, return 1, and it just adds all that for each of the columns. So it gives, so with this I don't have any missing data in my data frame. So this makes sense. There is a method called columns to show how many columns you have, like the different columns you have, and this just gives us the different columns we have. I think that's just a brief so we don't really have to do a lot of transformation because the data set looks clean enough. So you may want to see, okay, I want to see how many counts of the different, how many unique values do I have in my data frame. So rather than doing this, I can say, okay, df I can say, let's say for gender, I can say dot unique. This would give me, okay, I have male, female. I can also try, I want to see how many unique, different ways to go about that. I can do the n unique, gives me the count. So I could say, okay, rather than doing everything for each of the columns, rather than going through printing them one after the other, I can choose to something. I can say so I want to run a loop on my columns. For say for column, call in df.columns. Yeah, I can say okay, print. What am I printing? I want to print column. At the same time, I want to print column and print df. So let's try a different way. So you can say print column, also print so let's use our f string for this. Okay, so let's use I remember I taught you f string before. So I can say the number of unique items in use this. So again, if you don't know what f strings are or what a for loop is, I'm going to put a link to watch it at the info card, so you could just go and refresh your memory to understand what these are doing and how you create this and what they mean. In this column is like this a df call dot and your okay and unique. Okay, so what would this do for me? So I'm going to give for gender. I mean, I don't even need this because I'm going to call that there, so that's fine. I can print. Okay, so gender, the number of unique items in gender is 2. I can now say and they are, or let me print another one. So I can say print tf oh that's unique. What this we do with print, so this will just tell you how many unique items you have, and this will print out the unique items. So I can say for the number of unique items in gender is 2. The number of that's male and female, the number of unique items in race is 5. So we have B, C, A, D, E. The number of unique items in parental level of education is 6. So you can see the different items. So the number of unique items in lunches. So just have standard and free lunch. The number of unique items in test preparation course is this. And the number of unique items in mascot is 8. So you don't really need this for the numeric value, so you could have passed that out. Well, we can move on from there. Okay, so this will return all this, so we don't really need a numeric. So you could also modify this code. So let's just copy this. You could also modify this code so that it prints out this information for only the categorical value. So you can use this. Let's see. Let's use this. So it's more like select types only objects and keys too. So when you print this, it doesn't include the numbers. Yeah, so yeah, this just gives you an idea of how to get unique items in the data frame. So now let's start plotting. So in this, so let's just change this to markdown. So let's do let's plot histograms. Yeah, that's histogram. So let's start. We could start with plotting. So okay, we could start with plotting So now we'll go to histogram. We should start with let's plot the distribution for mascot. So remember matplotlib is PLT because we imported the matplotlib.pyplot as PLT. So we say plot.histogram, then we want to plot the mascot. Let's plot mascot and see what the distribution for mascot is. So you can see from this, you can see your distribution. You have the greatest number of people within 60 and 70. This just shows you the different distribution you have. You can also plot for other, you could plot other scores also. For histogram, you want to plot the numeric columns to like we still have almost the same distribution. So this just gives you an idea of what you have in your data. So I can say, let me plot what's the next one? Writing score. Okay, so let's see. So before you start your analysis, you already should know what your objectives are, the data, the kind of data you have, and what you want to see. That will guide the kind of plots you would return. So I remember telling you, okay, so rather than plotting these different plots one after the other, you could just plot them in one figure. So I'll show you how to do that. You can create your subplots, create subplots with your data. I also have shown you, I've explained the anatomy of this subplot or a matplot figure. So if you've not watched that video, I'll also put the description in the info card for you to go watch and understand how to create subplots and understand the anatomy of a matplot figure. Subplots. How many rows do I want each of it to subplot? And number of rows, how many columns? So you have function for n rows. Just want everything in one row. And n columns, I put n columns equals 3. You understand why I did this later. So we have big size. Big size. So the size of what's the size? How do you want your peak to look? You can always modify this to show how to give you the outcome you want. So this creates my plots. Okay, this should be a comma here. So if you plot, you run this. Fix again. No, this should be, yeah. I think I'm making a lot of errors. So big size. Yeah. Okay. Oops. So when you do this, it returns. So this is how your figure will look like. But I don't like the way this is looking. I don't like this. It's going to be overstretched. I want to make it. I want this to be smaller, so I should make it. Let's make this 5 and see what this returns. No. So I'll make this 3 instead. So I don't want it to be too long. This looks small. Let's even make it 5. No. 8. Okay, that's not bad. Okay. Fine. Why are you making me? You're making me look at. Okay, so this is a good size. So once so this, that's fine. So on our first axis we want to plot df dot a. So let's just go for the log one. This. So now we're not going to use the PLT this time. We're going to use, because we've already defined it here. So we're going to use our axis. Okay, no. So just do this. And so just duplicate that. So we're using indexing. So the first item is this first item is 0 index. This has first 1 index and 2 index. I want this to be reading score, and this to be writing score. Okay, what else do I also want to customize my blocks? I want to set axis, so I could also do the same thing, just the so the same thing. So the first axis, what do you want the name to be? First axis is to set. You want to set, say title equals to. So the first one is math score. So just copy math score is, and then just do this again. C. So I want this to be 1, this 2. So this is writing This is reading. So I time your money, so you have your, so this is, so rather than having them on different cells, you could just plot something like this and see all of them. So you could also plot, you do your figure to be 2 rows, 2 columns, just depends on how you specify the number right there. Okay, so if you want it to be, for example, if you want this to be vertical, all you need to do is just come here, plot this, and make this 3 and make this 1, so you have it in a row instead of columns. Okay, because of those, so we need to change this. I can choose to make this 5 and make this 15. So we have it, so you have them like this. So it depends on what works for you. You should be fine with everything. So next we'll be talking about bar plots. Bar plots are used to show relationship between a categorical value and a numeric value. Bar plots, so on for your x-axis you have your categorical plot, and the y-axis you have your numeric plot. So for example, let's plot the relationship between gender and, let's say, one of the scores. So do plt dot bar, I can say there gender, so I want my gender to be on x-axis. Also df, let's see, math score. So if I plot this, you see what returns. So you see how many math score, the different genders based on the math score, or the based on the math score or the gender. So I could try this for another, which other categorical columns do we have again? So let me just return the df the columns, see my column names. Columns to see column names. Just things and say. So let me try launch. Let me just try. We have more items here. Yeah, so let's just see this. So if you run this, so you see, oh, we have it just gives you an average for, I think this is the wrong thing I was supposed to do. It just said, so I'm supposed to use this. Yeah, okay. So you just see the average of, for example, will be what the average score, and it just gives you an average. So I want us to try something. So I want to plot the 3 numeric columns we have to see how they differ with the different, with, let's say, with male and female, or we could also try it with the other categories. So for this, I'll be using melt. Melt is a method, the pandas method, that helps you convert long tables to wide tables to long tables. Yeah, so if you could just go online and read about PD, let's say pd.melt. Melt, just go let's say .melt, you understand what it's. We have the pandas documentation for pd.melt. Pandas documentation for pd.melt. So you just go there and read through to understand what that's doing. Okay. So let's see. So what else? So I said I was going to use the melt. Okay, so I just want to do something like this. Okay, so what did we do here? So we melt. So we want the variables gender to be. So if we run this, so these are the values we want to convert to the long table. You understand why I'm doing this, to be able to group the data so that I can plot on the scores in it. So you remember how our DF looked like? DF was this. So now I've converted this white table to a long table. So you could just go with understand what the difference. So for example, you have female, you have their different scores. So for this first female, you have reading score, you have reading score of all the females. So you just repeat. So when you have all the reading scores you convert it to all those. But in this case, I just wanted only the gender, and I didn't want to pick, so only the gender and the different sports. That's what I did here. So these are the values I want to pick. The ID variable would be my gender, and just change the column name to score. So there, this could be complicated, but just take it one at a time. You understand what that is. So I just want to plot. I'll be using Seaborn to plot this. Using Seaborn to plot this, and I can customize my chart using this. So when I plot this, you'll be supposed to. Okay, so what is? Okay, no, this should be. Yeah. So let's run this. So you see, I've plotted all the different items I have. I have female. So for female, this is the average reading score. For maths, for female math score, this is writing score. This just shows different distribution. You could try this with different columns. So you could try this with the different columns you have. So remember, we have about 5 different categorical columns. So rather than doing this repeatedly, we could create a function that helps us do this. So all we need is we need to carry out. Also, let's see, how do you create function? You use the def, just column def and the name of the column you want. So I can say def plot, let's say plot bar. Let's call this our function plot bar. So what are you going to put inside? So I want the category I want to plot for to come out as that. Then all I need to do is this is what I want to use to create my function. Yes. So it's just to copy this in here. Okay, so I have this already. I don't need this. Delete. I copy this and also place it here. Okay, so let's use that. So you use just highlight and do control the bracket, the square bracket, the other part of the bracket just gives it that indentation. So everything we've just done here, I just want to put it in a function rather than always copying and changing the gender, everything. But I need to change a few things. So rather than using gender here, I want to change this to category, because that's so that whenever I give it anything, so I can change this at any time. So I also want to make this by category. So I'll change this to an F string also. Yeah, so F string. So I'll make this also category, because these are the things I want to be changing. So let's see what else this would be. Okay, so let's try what this will return. So I don't need this column again, so I could just call on this function I've created, the plot bar. And which column? Let's try with the gender column. So I need to also change this category. Yeah, so that whatever I put in, that's what will be called. So in this case, I want gender. To plot gender should be small g. Okay, wow. So now we have this. So rather than writing all the many codes again, I could just come here and use the next column I want to print. So in this case, I want to try the race and ethnicity. Just come back here and change this to race and ethnicity. Wow, so now you see the different scores based on the different group. I can still do the same thing. And in this case, I want to plot what else do I need to plot? I want to plot the launch column and see. Okay, let's see. Wow. You see, so these functions are very handy and very useful when writing your scripts, so that you avoid doing the same thing over and over again. Just call on functions, and so from this I'm already getting patterns. For the people with free launch, you see that they have generally low score generally across the 3 categories. I can also try the same thing with place. So in same case, the way we did it before, you could also write a for loop to just print out everything, to plot all this graph instead of doing going over and over. Yeah. So okay, so you could create a function. For example, so if when you see yourself doing things repeatedly, you create a function to help you rather than repeating yourself over and over again. So you could see from this, you can see that the plot size doesn't really work well for this. So you could also go back to your function to specify so that you can specify the kind of the size you want, the peak size you want. So what was the peak size we used the last time? I have this fixed size. I'm gonna make, let's see. So we want to change the default fixed size. Go there, please. So you can change your fixed size to accommodate. So if you notice, you see that the fixed size doesn't accommodate for this name. So you could just change the fixed size so that make it wider. Yeah, you can try that by yourself. So let's go. So let's try heatmap. Heatmaps are used to show correlations between two items. So just plot the correlation coefficient of our data of the numeric column. So let's try plot heatmap. Heatmap, I want to check heatmap. So any of these plots that you don't really understand, you could always go online, browse it to see what they do and what they're used for. As a data scientist, these are the things you want to check go wrong. Like when you see something, you want to go read about it to see how you can do it. So first, before we do, I want to create a correlation matrix. Correlation matrix for let's call this matrix. I want to create a correlation matrix for the df to see how they are correlated. So I can just put correlation one of this correlation. Yeah, so what does this return? What is representing this? So with this, you just say, okay, the relationship between these different scores. So you have breeding score. So for example, if you plot your X against Y and you plot breeding score against mass score, when you have your R square, like I know you might have done different plots. When you have a line plot or a scatter plot, you want to get your R square value as the coefficient of correlation. You see highly correlatable items will have high correlation and low correlatable items will have low correlation. So if you have a negative correlation, that means those items are not like the more one is increasing, the other one is. So if you have high negative correlation, you have that they are not correlated. So when one is increasing, one is reducing. Or if you have high positive correlation, as one item is increasing, the other is reducing. So this is what we have, but we can also turn this into a plot. So we use the Seaborn library to plot this one. So you say I want to plot correlation. So I just want to plot this. So correlation matrix. So this is what you get. So now this is just the item that just shows you. You could use this color bar to see, okay, which has, so this one's up or you have very high correlation, and when they this color, this very dark color, you have about zero. So it's difficult trying to pick out the colors from the color bar. So you could adjust, but let's just copy this. You could adjust this by, so we have this, so correlation, I want to really plot. So you want to see what are the different arguments you can put in this and see what you can. So just use your shift and tab will show you all the things. So you can specify the minimum value for your color map and the type of color map you want to use. So annotate. So the default is none, but I can change this to true. So let's see what that would do. Annotate and not equals true. So let's see what this does. So now you have your annotation, so you have the exact value inside each of the columns. So if you notice, you're always getting this plain. If you want to get rid of this, just use this to get rid of that so that it doesn't always show. You could also change your color. So let's try this also. And let's change the color. So again, if you use a shift and tab, you want to see they have different color maps. So if you want to know the different color maps you can use, so this explains the different things you can use, and you just go read and understand how you can change. Yeah. So I was going to go talk about the CMAP. So there are different CMAP. So you want to see the different CMAP, just go online and type CMAP. Let's try. Let's say PLT CMAP, CMAP, CMAP. So I want to see the different color maps I can use and what they represent and different colors. So you see different color maps. So you choose whatever you want, diverging, that. So you just go and pick the different CMAP you want to use. But for let me try the CMAP. Let's see, CMAP was let me try pull one and see what is returned. Let me try one. Let's try pull to see what comes up. So this is cool. Let's try one. No, so there's no color like that. Not. So this shows you. So it turns out it's not a valid color. So these are the different colors you can try winter. Let's see what winter returns. Let's try winter. So it shows you different color bands. So you just play around till you get the one you feel you're comfortable with. So I changed this to, yeah, so just play around that and you should be able to get something that works for you. So we'll just quickly move down to let's try scatter plots now. So let's scatter plots. Scatter plots. Scatter plots are used to show relationship between two numeric variables. So I could say, let's try we could use data frame to plot our scatter plot. So let's try plot.scatter. Let's try scatter. So what columns do we have? So we have the math column and we have y column. So let's try plotting math. So let's say math score, and reading score. Let's see what this return. So this just plot a different it just plots different scores on it, the x against y, so reading score against math score, and you can see this. But with this you can't really tell uh anything. What the main thing you can tell from this, you could say, okay, there's a positive correlation between your math score and your reading score. So you could also want to add some fill to your score, for example. So I can say, let me make this just gives you math score. You could customize this and say, let me make my color. So if you also come again, you do your shift tab, you see how you can customize this and the different things. So see string option, like it gives you the size of your page. So if I want to change the color from blue to something else, I could say C equals to red. Let's make a plot red. C equals to red. So now it's been changed. If I want this to be blue, not that other shade of blue, the change this depends on the color you want. Right? But this doesn't still change anything. It still gives us the different, like we can't really say anything of the relationship between the scores and any of the categorical value. So to identify that, we use our CBON. So we have CBON as SNS. We can say let's plot a scatter plot. So CNS to scatter. Want our data, so you have to specify what data. So I'm using my DF. I want what's my x value to be my math score. X value to be my math score, my Y value to be, let's say, reading score. So this is my reading score. And let's plot this and see. So these two, SNS to scatter plots. Let's scatter now. Scatter plots. Yeah. So the same thing. So the same thing you have here, but let's start adding color. field to upload. So you could use the parameter here and say, okay, I want this to color by gender. That's what is you meant. So you plot this. You see that, okay, oh, this is now making sense. So you see the blue are females and the orange light colors are the male. From this, you can already see a pattern between the male and the female. For example, you see that male they have more, the female have generally have higher score, higher rating score as compared to the mask compared to the male. So with this, your idea in fine trend. So generally, our female have higher score, but if you look at down here with people with very low score, you see it's tend to be populated more by the females. You want to ask yourself, why would there be any relationship? I expect my females to have higher score, but the lowest score reading scores are female. So why as compared to men? So you want to start digging deep to understand why this is. So I want to check and say, okay, see, and say, okay, let's try something else and say, let's put style. So the style will be so now we have generally circle. So if we use style, say, okay, let me try, what columns do I have in my data? Let me say, df the columns again. I want to see my columns. So I can say, let me make my style, test preparation course to see if we can see any relationship between that. You can see no significant relationship between these, whether they completed or not. So I can just copy this and also let me try launch. Let's see, let's try launch and see if that will give us any pattern. Launch. So this is this. So wow, so this I think this makes sense. So you see that the females with the people generally with low scores are the people that had free lunch. So those cross the what the X sign out for free lunch and the zeros, the normal and the standard lunch. So you notice that people generally with free lunch or reduced lunch tend to have low scores. So you can start asking yourself, you already have answers to these questions you're asking yourself. So you see that okay, if you want to increase people's scores, you want to say, okay, maybe the free lunch is affecting how they prepare for their exams. So this is how you start getting insights from the data, making conclusion, making different things. Also, aside from using style, you could also use let's see, rather than using style. So if you come again with catapult, you see you use your tab and your shift and your tab, you see all the things you can write. So we have size. Let's see what size does for us. Let's see. Let's see what the size would do this time. No, so I was gonna use size. What do you think is will return? Do you see the size of so standard launch have higher circles and people with free launch. So you notice that a combination of factors leads to the results they have. So most times, so although we have some people with standard launch having low score, but like it's a combination of different things. So as a data analyst, you're trying to dig in. So as a data analysis, you're further digging, you're trying to further dig in to understand why these different variations in your data. So you can have a combination of different things. So you can have size as launch. Let's add your style. So you can just compare multiple categorical value to see how they affect your data. So let's just get let's see how race and ethnicity affect the scores. Okay, so I can't really get any significant pattern with race and ethnicity doesn't really affect much. You can see so this is just the exploring to see to answer questions and yeah, go through. So I would like to see what you've done. So you can try these, add your own flair to it, add your own plot. and share your script with me. I'd like to see what you've done, how you've achieved this, and what what deductions or what new insights you're getting from this data. Thanks for watching. See you on the next one.